have a particle of mass 2 kilograms, just going to underline that, moving on a smooth horizontal surface under the action of a single force. At time t seconds, then we have the velocity relative to a fixed origin, and it's given by this. So I'm straight away going to put it in vector form. I just think it's easier to deal with. If you want to deal with i's and j's throughout, then of course you can. P and Q are constants, and P is less than 0. Just going to underline that. Now, we're given that when t is equal to 0.5, the magnitude of f is 20. Find the value of p. So I'm going to need to use f equals ma to link in to the motion. And that means I'm going to need to work out a, which is the derivative of the vector dv by dt. So for this, we just differentiate the x component and the y component separately, no problem, which is going to give 2pt minus 3 and then 8. And then when t is 0.5, a is then going to be, or 2 times 0.5 is just 1, so we get p minus 3, 8. Okay, now I can apply f equals ma. So for us, it's going to be that mass 2 times p minus 3, 8. We're just multiplying a vector by a scalar. It's going to be 2p minus, I could put it in brackets, but I'm just going to multiply it. 2p minus 6 and 16. So f, the magnitude, is 20. And I can work out, I can use Pythagoras' theorem now, basically. I can draw a little triangle. I'm going, got 2p minus 6 in the x direction, and then 16 up, and then that's 20. So 2p minus 6 all squared plus 16 squared is equal to 20 squared. Now you could expand this and then solve a quadratic, but there's no need because this is essentially in completed square form. So I can just say that 2p minus 6 squared is 20 squared minus 16 squared. So it's 144. And then square root 2p minus 6 is going to be plus or minus 12. Adding 6, I'm going to get 18 or minus 6. So p is equal to 9 or minus 3. Now, I underlined it earlier on, just make sure you make a note of this. P has to be less than 0. So I'm actually going to reject the positive one in this case. You quite often reject the negative, but not here. So P is equal to minus 3. Okay, that's that bit sorted. When t is 0, r is at the point, that's the particle, with position vector 2i minus 3j. Find in terms of q an expression for the displacement vector of r at time t. Right, I might have to scroll back up in a minute, but I'm just going to get a diagram down. So I've got an origin, and I've got my position of the particle, and I've got this position vector. Now we can look at finding s. So the displacement vector is going to be the integral of the velocity vector. But remember now I have that p is minus 3, so it's going to be minus 3t squared minus 3t. So again, if you want to use I and j and do it separately, you can, but this is just a bit more concise. And then I've got 8 t plus q, integrating with respect to t. So this is going to give minus t cubed, because I raise the power by 1 divided by the power, new power, minus 3 over 2 t squared, 4t squared, plus q t, plus an arbitrary integration constant. Now I could write it in vector form. It's like c1 or cx and cy, but I'm just going to leave it as it is, I think. Now we know when t equals 0, that s equals 2 minus 3. And so we can substitute in 2 minus 3 is going to equal, well, actually, all of these just become 0. So 2 minus 3 is simply our value of c. And finally, we can write down that s is going to be minus t cubed minus 3 over t squared. Then I can add the 2 on inside here. 4t squared plus qt minus 3. Now for the final part, we're told when t is 1, r is at a point on the line L, where L passes through O and the point with position vector 2 minus 8. Find the value of q. I had to reread this a few times, just get my head around what it was actually saying. Let's draw a diagram. So we've got the origin, and we're told, so r is at a point on the line L, where L passes through this origin, and the point with position vector 2 minus 8. That is not saying that r is 2 minus 8. It's just saying there's a point here where we get 2 minus 8. What that actually tells us is this point r up here is going to be a scalar multiple of that. So, for example, 2k minus 8k. Just need to introduce a constant in there. We're timesing 2 minus 8 by a constant. We know it's along this line. It's a vector that is just yeah, a multiple of 2 minus 8. And this is when t is equal to 1. So now I can use this and sub in. Therefore, I will have 2k minus 8k equal to minus maybe 1 cubed, and then making it minus, that's going to be minus 1, then minus 3 over 2 plus 2. On the bottom, we've got 4 plus q minus 3. So it's been quite kind in that it's used 1 because all these t's just basically go. And that is going to become, well, minus 1 plus 2 is 1, minus 3 over 2, we're going to get minus a half. And then over here, it'd be q plus 1. Now, if you don't quite realize to times through by k, and you just set 2 minus 8 equal to it, you'll be able to see that you've made a mistake. We can't have that 2 is minus a half. Then at that point, you might realize, oh, okay, it's not equal to 2 minus 8, it's some multiple. And you might, however you get there, you might just think, right, I need to times it through by minus 4, and therefore I need to times the 8 through by minus 4. But anyway, with the k in it, it does work out really nicely. So now I can say that 2k is equal to minus a half by equating these x coefficients, which means k is going to be minus a quarter. And that means if I take the bottom one, I'm going to get 2 equal to q plus 1. Therefore, q is going to equal 1. That's the question done. So to summarize, we've got variable acceleration here, but we're working in 2 dimensions, which brings in vectors, but we're still doing the same sort of thing. We're differentiating, we're integrating after we're starting with velocity. Just work with the vectors, draw diagrams. That really helps, I think. Read the questions like multiple times and you get there. Good job.